So on your homework the other day, you had a section where you had to complete the trinomial so that it would be a perfect square trinomial. And we're going to do a little more practice of that today. And we're going to follow this set of directions. Where it says to complete the square for the expression x squared plus bx, you're going to square half of the coefficient of the term bx. So if the coefficient of x was b, you divide it by 2, and then you would square it. The reason it is because we know that if you have a plus b, quantity squared, if you were to multiply that out, it ends up being plus 2ab plus b squared. So to work backwards, you'd have to have half instead of doubling it. So look at number 1. If we wanted to find the value of c that would make the expression a perfect square trinomial, what would we add? Michaela. Well, we want to take the coefficient of b, right? So the coefficient of b is 4. So you're going to take half of 4, which is 2. And then when you square 2, what do you get? 4. So the answer for C is 4. If you had x squared plus 4x plus 4, that would be a perfect square trinomial. All right. Then it says, then write the expression as the square of a binomial. How does the x squared plus 4x plus 4 factor? You should all be able to factor this trinomial I just put in the box. Oh, I have 3 hands up. Kevin, what do you think? X plus 2 quantity squared. So let's look at this. To get C, we took the half of B and squared it. But before we squared it, half of B ends up being what we have here. Interesting. So that follows this model. We have b over 2 squared makes our new value of c, and then the b over 2 without squaring it is what ends up being in our factored form. All right, let's try it again. So first, what am I going to do for number 2? I need to find half of what, Anna? So half of negative 20 is negative 10. And then what do you do with that half of value? Square it. So what is c? 100. Positive 100. Now let's write it as a trinomial. X squared minus 20x plus 100. Now write the expression as the square of a binomial. Let's see. I want different hands up, please. Tate.
X minus 10 squared.
X minus 10 quantity squared. Fabulous. Now, when you get a problem with a value of b that's not even, we start to feel a little panicky. Don't be panicky. You're just going to have fractions, and it's going to be easy fractions. They're halves. So what's half of 9?
4.5.
Now we're not going to have it as a decimal. Let's leave it as an improper fraction of 9 over 2. Then it says to square that whole value. So I'm going to take 9 over 2 and square it. What do you get?
81 over 4.
81 over 4. Nice. So our trinomial is x squared plus 9x plus 81 over 4. Have I lost anybody? Any questions so far? I'm taking half of b and I'm squaring it to get that value of c. Now I want to write it as a square of a binomial. Chanel? X plus 9 over 2. Nice. You guys seeing the pattern? That what's inside this square ends up being there, and when you square it, it's the value of c. Nice. I'd like you guys to finish 4, 5, and 6 in the next 2 minutes, 3 minutes, and then we'll move on. All right, you may not be done, but let's go ahead and see what we have so far. Who has number 4? Coleman.
X minus 2 squared.
Well, let's first start with the value of c.
Alright.
So half of
Half of negative 2 is 1.
All right, and then you square it and get that c is.
Positive 1.
So we have x squared minus 2x plus 1 is our trinomial. And then what? How do you write that as a binomial?
X minus 1 squared.
X minus 1 quantity squared. Nice. All right, who has our number 2? Michaela.
So first you do a half times 3 over 2.
Yes.
And you get 3/4 squared and 9/16.
So your trinomial is x squared plus 3 over plus 9/16. Nice. And then your binomial squared is?
X plus 3 over 4 squared.
Nice. Perfect. All right, so then this last one, go ahead, Tate.
Okay, so you do, I think 2m over 2.
Well, just the coefficients, so you don't need to worry about the m's and x's.
So 2 over 2.
All right,
And then you get 1.
good. So your trinomial?
Would be x squared plus 2mx plus 1.
Plus 2mx plus, how are you going to get not just 1, but plus m squared, actually?
And then it's x plus m squared.
Perfect, quantity squared.
Why is it m squared?
Well, how else are we going to get an m in our middle if we didn't have an m to begin with? M times m is m squared, x times x is x squared. Multiply them together and double it to get the middle one. Yes, Eli?
Do you think of m as part of the coefficient though, because it's
Yeah, part of b.
No?
because it's 2m is b, not.
Well, you're just treating it like it's like it's another variable. So what we really just need to divide in half is the 2. Okay? All right. Now, if we can write things as a squared quantity, then we can do what we did yesterday, right? We could square root each side and solve. Well, so let's figure out how we can take an equation and use what we just did to solve it. And this is especially beneficial on equations that do not factor. So this method is called solving a quadratic by completing the square. So I'd like you to follow with me step by step. You're presented a problem in a different form. This one's in standard form. The first thing you need to do is move the constant term to the right side. So I'm going to move this 20 over here. And I have to use inverse operations to do that. And watch as I write that I'm leaving some room after my 8y. So now I have positive 20 over there, right? Right. Then it says add b over 2 quantity squared to both sides. You have to add it to both sides, otherwise you'll change the value of the equation. But when you add the same thing to each side of any equation, you don't change the value and it works out okay. So what's b over 2? 4. So 8 over 2 is 4. And then what's that squared?
16.
So I'm going to add 16 to each side. Alright. Then it says to write the left side as a square of the binomial. So y squared plus 8y plus 16, just the left-hand side, is a perfect square. Who can write that as a square of a binomial? Kiani.
Y plus 1 quantity squared.
Y plus 4 quantity squared. Nice. Why is it y plus 4? Well, here's the 4. We said it was 4. Think about how you get from a perfect square trinomial to its factored form. All right, Ty, what's the left-hand side of the equation going to be? Oop, I'm sorry, the right-hand side.
36.
Nice. Then it says to take the square root of each side. Once you guys get to this point, it's just like yesterday. We're going to take the square root of this side and take the square root of that side. So, Will, I'm going to write this as y plus 4, but what should I write on this side?
Plus or minus 6.
Plus or minus 6. Good. Still have to consider negative and positive solutions, just like we did yesterday. Now, if there's a radical, you'll simplify it, but then you want to isolate the variable. So I need to isolate y by subtracting 4 from each side. So I'm going to have y equals negative 4 plus 6. And I'm going to have y equals negative 4 minus 6 to get your two answers. Separate them at that point. So we get answers of 2 and negative 10. Sometimes you'll have radicals like we did yesterday. It's okay. That's the whole point of doing this, so that you can solve equations that do not factor. Now, this one would have factored. Who can factor that equation for me? The initial one. Who could factor this? Raise your hand, please. Megan.
Would it be y minus 2, and then on the other side y plus 10?
That's the correct factorization. Look, it looks just like the opposite of these. Nice job. Well, in the future, not on today's homework, but in the future, you're going to be given a choice. You'll get to choose whatever method you want to solve these. Well, if it can factor, it's to your benefit to factor it. However, completing the square is a very fast method of solving. Alright, so number 8, let's follow the steps again. Do we need to move the constant term in number 8? What? No, it's already on the other side. The 112 is over there. So I'm going to start by writing it such and leave some room after my 6x. What is b over 2?
Negative 3.
Negative 3 squared is? 9. But I can't just add 9 to one side. I have to add 9 to both sides. Okay, so the first thing I did was negative 6 over 2, negative 3 squared. That's 9. Okay, now let's go ahead and write this trinomial as a squared quantity. Ty, what is it?
X minus 3.
Perfect, quantity squared. And 112 plus 9, luckily, is nice and even, 121. I say even, but I mean that'll work out nicely. All right, Evan, what's my next step?
Well, you're going to write down x minus 3 equals 11.
Well, I'm going to square root each side.
Yeah.
And I have x minus 3 equals just 11, or plus minus 11. Now I'll separate it, and I'm going to add 3 to each side, so I have 3 plus 11 and 3 minus 11. And you have your two solutions of 14 and negative 8. All right, turn the page. Let's see what happens when we have to involve a rad. Number 9, same deal. It's already the constant term has already been moved over. Ty, why don't you walk me through this one?
Okay.
All right.
So you go 20t squared plus 10t plus 25. Oh.
So you're gonna go. You went b over 2 and got.
Oh. I'm gonna 5 and then just square it out.
You get 25. So we're gonna add that to both sides. Good. Now factor the trinomial.
And then you get t plus 5
Good.
squared equals 45.
Nice. Everybody to that point?
What?
I'm just stopping. Is everybody to that point? All right, Ty, you want to finish it up?
And then you square both sides.
Square root each side. Good.
You get 2 plus 5 equals plus or minus.
Let's see. 9 times 5 is 45.
So 3 root 5.
3 root 5. Awesome. Subtract the 5 and you're done. Nice job, Ty. And we're going to leave it like that. If the directions say to provide an approximated answer as well, then you can. I think our homework's out of the book tonight. Let me double check. Well, I'll talk to you about your homework after lecture. All right, I'd like you guys to go ahead and do number 10, and then we will go over it. Hold on. All right, so what do we have as our b value? So our b over 2 value is 1/2. And then you square it, and what do you get? 1/4. So I would have x squared plus x. I need to move this 1 over there. And then what we're going to add to each side is 1/4. Is everybody at that point? Go ahead and factor the trinomial. So that will factor as 1 plus, or x plus a half. And then let's write this as a 5 over 4. Thank you. I was going to try to say with a common denominator. Take the square root of each side. Now when you square root the fraction, we can do the square root of 4. So your denominator should be 2, but leave 5, root 5, like that. Okay? Now our last step is to subtract 1/2 from each side. So I get x equals negative 1/2 plus or minus square root of 5 over 2. Now that answer is technically correct, but we have a common denominator, so we could write this as one fraction with a denominator of 2. So I'm going to write this instead as negative 1 plus or minus square root 5 all over 2. Either is correct, but this is the preferred method at Harvard-Westlake. Yes, Chanel?
I did plus or minus 1/2 times root 5. Should I do it that way?
You did plus or minus what?
1/2 root 5. I
think you multiplied instead of subtracted?
Yeah.
Alright, so make yours look like mine. Guys, we're going to do one more as a class, and that's number 11. We don't like having to deal with a negative squared term. So what could you do to get rid of the negative squared term? Ingrid?
You multiply everything by a negative?
Yeah. Let's get rid of the negatives. Minus 2y minus 17 is 0. Griff, what was your question?
You could just move the y squared plus 2y to the other side.
You could? Yeah, that does the same thing. So now I need to move my 17. I leave some space so I don't have to write it all over again. And my b value is negative 2. So negative 2 over 2 is negative 1. Then you square it and you get 1. So you have to add 1 to each side. And that's probably the most common mistake when kids are completing the square, is they don't add their b over 2 squared quantity to each side. Alright, now go ahead and factor the trinomial. You have y minus 1 and 18. Root each side. Plus or minus what? Who can simplify the rad for me? Anna? Thank you for raising your hand. Good job. Add 1 to each side and we're done. And I know it looks funky, but that's the most exact answer because it doesn't approximate the value of square root 2. Alright, good job you guys.